Hello, welcome back to another coding video on the Bin Mentor YouTube channel. Today we're going to be learning how to access elements coming from linked models. So I already have a Revit sample project that has both an architectural and a structural model, and I have linked the structural model into my file. As you can see, it's highlighted in blue, meaning that it's a link. So we're going to be accessing this link and also reporting the number of columns in the model as an example of a way of filtering through data in a linked model. One of the best use cases for this could be to further develop a quantification tool if you want to do something a bit more elaborate. But we'll take baby steps today and just learn firstly how to access the linked model and how to also return a count of all the columns in the structural linked model. The main class that we will be needing today is the Revit link instance class. We'll be accessing this class using a regular filtered element collector and with a for loop combining an if statement. We'll go through the link instance and return the name of the link instance, which in this case will be a Revit structural project. And we'll also return how many columns are inside that structural model. Now, if you've never looked at filtered element collector or you don't know what a for statement is, I am linking two videos right now that will help you understand the syntax for them. And if you already do, then this video is going to be fun because you're already familiar with the syntax. As always, we are starting off in Visual Studio. I've already gone ahead to create a class and call it Edit Linked Model class. You do this by right-clicking on your project and clicking on Add New Item, and you can create a class. If you've been following my videos so far, we've already gone through this process, so I'm going to skip it this time around. And you should also have the boilerplate from my GitHub page, which is linked in the caption, that already sets you up with your UI app, your UI doc, and your doc, which is usually what we would need to filter through to get any elements in our models. So once you have this all set up, then let's get started with accessing our linked file. First thing we want to do is filter through the model and return the instance of a link that we have. So I'm just going to leave a comment here that says returns link instance. And then I will start off by creating my filtered element collector. So I'll call it collector and instantiate it for the first time as always. And as always, we'll be filtering through the entire document. I'm going to tab to implement this code as this is exactly what we want to do. Perfect. The next thing we want to do is to create a list that will be the host or the house of the link. So we need to store our link in a variable of sorts. Because it's possible to have more than one link in a model, that's why we're using a list. Otherwise, we would be using something more like a variable just to store this. But in this case, we are only dealing with just the one link. However, you may have several links even for the same discipline. So that's why we're using a list in this case. We're going to be creating an iList, which is an interface of the list class. And we're going to just let it host element in this case. Let's call our iList link instances. And inside this iList, we're going to go with our collector and say filter for elements of class, as always, type of, to get the specific type that we want of that class. And what we want in this case is the Revit link instance class. I'm just going to click on this since it's been suggested already. And then I will cast it back to my list. Okay, so this code already will return how many links or the specific instances of links that we have in the project. But even when it does this, we don't really see anything happening in Revit. Like this doesn't return anything back to us visually to tell us that it's collected the link. So let's create a task dialog that will sort of run through all the links in the document and then return that link name. So return the file name. So we use a for each loop in this case. So for each, and we'll call it link. So it's a variable that's going to be coming from the Revit link instance class. Let's just call it link. In this list of link instances. So inside our for loop, we want to create a doc that will have all the methods associated with the doc, right? So that's like an instance of the document class. We'll call that link doc. And we'll say link dot get link document. That's what we want. This will return the actual link documents that we have in the overall Revit document. And we also want to return the name of the document in a task dialog. So we'll just say task dialog dot show. And inside the task dialog, we want a linked document as the title. And then we want to actually return the name of the file. So let's just start off with the first portion being a string. And then concatenate this with a method that will actually return the title of the file that we have. So the file has already been extracted here as the document. So let's just say link doc. And then we will access the title method of this linked doc to actually return the title of the file. There it is, title, and end with a semicolon as usual. And this code will actually return the name of our link. The problem here is sometimes they may not actually be any links in the model, and then this code is going to crash Revit. So what we want to do is to actually wrap this in an if statement. So we'll say if linked doc is not equals to null, which means that there is actually a link in the document. It's not null or empty. Then, and only then, return a task dialog. So we're just going to wrap this task dialog inside our if statement. And this is just to keep your code error proof. It's good practice to always use if statements, try catch statements. Just it's called error handling in coding. So it's just best practice for removing anything in your code that could potentially cause your software to crash. So we have the task dialog already showing the title of the document. What we also want to do is add the number of columns inside the model. So right above the task dialog, let's actually create another filtered element collector that will return the number of columns in the model. So I will leave a comment here just to say create a collector for columns. This will just help us know what this part of the filtered element collector is doing. Clean that up a bit. So as usual, the syntax is filtered element collector. This time around, let's call it column collector since we already have collector in use for our previous one. And as usual, we say new. But this time, instead of accessing the overall document, we will be accessing our linked document. As usual, it's going to be ilist going through elements. And this time around, let's call it columns. And we are going to be accessing our column collector, similar to how we accessed the collector initially. But this time around, because we're filtering through the link, we're going to be using the column collector. So let's call this column collector of class, as always. type of, and there is no column class in this case, it's actually a family instance. So the type of that we want is a family instance. And inside of that family instance, we want to drill down to say of category. So now we're specifically going to the category of columns, and it's a built-in category. So we're going to say built-in category and just clicking to implement that, and accessing the method OST structural columns. It's good to make the distinction here that it is actually structural columns and not just architectural columns, because they would be different family instances as far as Revit is concerned. So you could scroll down or type. I'm just scrolling down to give you a visual idea of all the different categories that you can actually access using a filtered element collector. Scrolling all the way down to S to find the structural column. And we are here. There it is, OST structural columns. Just because this is getting a bit too long, I'm going to move this down by pressing enter. And we're not done yet. We need to actually cast this filter back to our list. So we'll say dot to list. So this is usually the syntax for filtered element collectors in general. And they're one of the most useful part of coding with C# and the Revit API. So all we have to do now is to actually use this list that we've generated of all the columns in our project and put it back in our task dialog to say how many columns were in the project. So we're just going to add to the task dialog that we already had. So I'm going to have another plus here, and here I'll put a comma just to separate them, and a space. Another plus just because I want to add the number of columns, and I'm using the count method that can be applied to any list. So it will be columns dot count. And then using the plus again, I'm concatenating a very long statement here. I'm going to say columns found. And it will return this as linked documents. Let's just say and number of columns here as the title of the dialog. And it will return firstly the name of the model. So linked model is linkdoc.title and comma space, and then number of columns plus columns found. It will make a lot more sense once we actually run this. Because we are using the Revit Addin manager, we will be debugging instead of going into debug by saying build, because we just want this to be built and updated in the Addin manager. Before you do that, make sure to update your Addin manifest file with edit linked model. You do that by changing the full class name to access edit linked model, and also creating a new GUID and updating the GUID. All of this boilerplate code is found in the GitHub page as well. Once that is done, all you have to do is click on build, and it will build the solution. Build succeeded, no errors. So let's hop into Revit and see how our code is working. So back in Revit, we'll go into the Addin Manager and click on Addin Manager Manual Mode. And without doing anything, because I was already referencing the same DLL from the last video, it's already loaded the create elevation from the last video and the edit linked model from this video. If for any reason you don't see the updates you've made, try to check your manifest file to be sure that it's correct, and maybe try reloading the original DLL that you had just so that this updates. But this is the perk of using this tool, is that you don't have to keep debugging and building and checking the folder each time. As soon as you update your original package assembly, that's the BIMmentor.dll, it will update every single additional class that you make. So the one we want is this one today, and I'll click on it and I'll say run. And there we have it, linked model with the name, comma and space, 203 columns found. So that means there are 203 structural columns in our structural model. This could be advanced further by actually doing some calculations, like putting some mathematical functions in our code to use this for quantification. There are many ways to develop this further into something more complex, but I think that for a start, we've learned today how to actually manipulate linked models as well as our active Revit model. Thank you for watching, and I'll see you in the next one. Before you go, please leave a comment, like, or subscribe. Engagement really does support me on this channel and it helps me to keep going. Thank you so much. I'll see you soon.